Hi everyone, in this video we're going to go over another Leetcode question, Kth largest element in an array. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Find the Kth largest element in an unsorted array. Note that it is the Kth largest element in the sorted order, not the Kth distinct element. Example 1, 3, 2, 1, 5, 6, 4, k is 2, output is 5. So k, the largest element here, second largest element is 5, and we return 5. Example 2, 3, 2, 3, 1, 2, 4, 5, 5, 6. And k is 4, and kth largest element, fourth largest here, 4. So kth here is asking kth largest element in the sorted order. So intuitively, we can say if we sort this array, in the ascending order, all the smallest items will be in the beginning, and all the largest items will be in the end of the array. And the kth largest element will be the kth element from the end of the array. So we can use that using Java's built-in sort method, and that would give us O(n) log n time complexity, and we can solve the question easily this way. But we can improve it. I mean, O(n) log n time complexity is not great, so there should be better way of doing this. When you see largest, smallest, etc., you can always think heaps. And using heaps is another way of solving this question. Excuse me. Yes, I said using heaps, either min heap or max heap is one way of solving this question. There are other algorithms as well. Let's discuss heaps and how we can solve using min heap and finding the kth largest element. It's the largest element what we're going to use min heap. Let's see heap visualization here. So this is our heap, and our smallest element is in the beginning. It's a min heap. I want you to see how it works when we pull an item from the heap. This is the swapping and how heapify works. It's basically bringing the last element here and puts it here, then starts swapping using comparison and sorting the heap. So let's remove again. So swaps and builds the heaps. So the idea is, if you're looking for the kth largest element, if you look at this, it's this sorted order array. If I'm looking for the kth largest element, this is the element. If I get rid of all these numbers, all these elements, and only k number of elements left, and when I check the first element, that will be the kth largest element. So that's the idea. So removing all the elements is going to take some time. Let's see this in a smaller example. And I'm looking for the third largest element, for example. We are going to pull the elements until we have only k number of elements left. So pulling. One thing to note though, in the algorithm that we will be implementing, we are going to pull while we're building. So it's not going to be like this. It's a little different, but it works the same way. Remove the smallest. And I'm looking for this number. When I say, okay, heap.poll, that will give me heap.peak. That will give me this number. So let's see this in the algorithm. To build the min heap, we're going to use priority queue. Then we go through the array and add them into the heap. As we go through, if we have size greater than k, we start pulling, and we have the size of k left in the heap. And finally, after this, we simply peek the first element, and that will give us the kth largest element. And this happens in O(n) log k time complexity. So this is much better. Let's see this in the code. Let's put it here. So run the code and see. Okay, this works, and so this worked for this one. So basically it's a simple thing. Just have a look at this. This is the link, and we are basically polling until we have k number of elements in the heap. And building heap is easier than arrays built-in sort methods, so it's much faster. So that's why we use heap, and that's the answer here. I hope you found this one helpful, and I have more videos coming up. So if you subscribe to my channel, we can meet again in the near future. Thanks for watching. Goodbye.